things. In this one, let's talk about the product of functions of namely f and g. If we have f and g prime in respect to, we can say for example a, so in respect to a, it should be equal to f prime of a times g of a plus f of a unchanged times g prime of a, where the prime denotes the derivative of the respective function. So this is how to look at the derivative of a product of two functions. The derivative of the first times the second plus the first times the derivative of the second. And now let's prove this interesting theorem that basically says exactly this. So let's now prove it. The proof will consist of a straightforward algebraic use of algebraic rules and the general limit definition. So we can view this whole thing as the limit of h going to 0 of, it's going to be over h, but it's not going to be simply f of a plus h minus a, but this is now going to be a product of f and g. So we have to have a plus h times g of a plus h minus f of a times g of a. So the second term reminds more of what we actually were looking at. And now what we have is, we can start rewriting this slightly. We can add terms that weren't there and subtract them back to make it equivalent, but use them for some algebraic manipulations to gradually get to some point with it. So namely, we'll make this expression even longer now. We'll rewrite the same terms that were there so far. So that will be this. We subtract that second term at the end, but we insert a new term in the middle that wasn't there and subtract it back. So we would do it like this. Namely, that term is going to be this f of a times g of a plus h. So it's going to be f of a plus h like this, and then subtract it back to make it like it's not there, but it is going to be used for the algebraic rules to get to the conclusion here. So the next step we take is we realize this and we isolate one of the g of a plus h. Namely, we'll take the one at the term f of a plus h and f of a. So what we get is g of a plus h times this thing f of a plus h minus f of a. Of course, everything will be over h, all right? So I now have to prolong this parentheses in an unnatural looking way because it's just a very long expression. So that's the first part we get. But another part that we get is going to be the following. We also can do f of a times g of a plus h minus g of a. And this is helpful because it lets us actually directly see now the derivative pattern, what it actually says. What this actually all along says is we can now notice, now of course this is over h, I mean this whole thing was meant as a single fraction, but it was just very long, so it went on two lines. So what we actually get is the following. We get limit of h going to 0, and this is by limit properties. The addition can be put into two separate limits with the same limit value. So what we get is basically a limit h goes to 0 of f of a plus h minus f of a over h, but plus the g a plus h like this, and all of that, of course, over h. And then we have the following. We have also plus another limit. So we basically just separate out what we had here. We just reuse it. This is times. It was a mistake. So this whole thing. And then another limit, which is going to be this time g of a plus h. So that's going to be the g function minus g of a. And all of that will be times f of a over h. So here we can spot the limit derivative, limit definition for derivative of g. Here it is for h. But we also realize that if we add h goes to 0. In the numerator we can see now h as 0. So this thing will basically become g of h. And this is already f of a without a problem. So this is all basically f prime of a due to this part, and this gives g of a. And then we add, this is g prime of, so here we have g prime of a times the f of a, which we see is exactly the expression we wanted to get to. It's just a flipped order a bit. This is just flipped, these two terms, but multiplication, of course. So that's that.